Okay, the next, I'm going to do 4 videos this time. The next 4, these 4 will all be part of the power rule. And remember, the lead coefficient gets brought out. So you rewrite it like that, and then you begin the integral process. So capital F of x is equal to -4, and then we're going to add 1 to that 2. Well, -2 plus 1 is -1, so then we need to divide by -1, put the plus capital C. -4 divide -1 is just +4. And then now this is x to the -2 plus 1 is -1. So that's going to come down here and be in the denominator. Anytime you have a negative exponent, remember the laws of exponents, you need to rewrite it with a positive exponent by putting it in the denominator because it's a reciprocal, right? So here is our final indefinite integral. All right. So now let's do another one. This one looks a little bit harder, but notice -4/3 just gets brought out, and then you have x to the 1/3 dx, the integral of x to the third x to the 1/3 dx. All right, so capital F of x is equal to -4x 4/3, and then we're going to add 1 to the 1/3, but instead of writing it as 1, write it as 3/3, so it's easier to deal with. So that's what we did here. So 1/3 plus 3/3. Well, those two add together to be 4/3, so that's what we divide by. Well, -4/3 divide +4/3. You don't even need to multiply by the reciprocal. Those cancel, leaving -1 or just a negative sign. And then what we have left is capital F of x is equal to negative, or you could put a -1 there if you want, x to the 4/3 plus c. Another way to write that instead of fractional exponents is write it as a radical. Negative cube root x to the 4th, because remember, the denominator is the root and the numerator is the exponent. Okay, so let's come over here. We have a -5 that can come out, and then that can be rewritten. But notice that becomes a rational function, but instead of 1 over x to the second, we're going to rewrite it as x to the -2 dx. And that's what I did right there. And then we're just going to use the power rule. So f of x is equal to -5. Again, x to the -2, we're going to add 1, and -2 plus 1 is -1, so we have to divide by -1. -5 divide -1 is +5, and then that becomes x to the -1st, so the x gets moved to the denominator, and that's your final answer. They don't really need to be that far apart. I don't know why it's that far apart. That would be kind of a silly look, but anyway, I'm criticizing myself as I do this. So this one looks a little bit more complex, but it really isn't very complex. There's a -23 that gets brought out, and then this cube root of x squared you can rewrite as x. This is the exponent, this is the root. The exponent is the numerator, the root is the denominator. So we're going to rewrite it like that. Kind of looks like a 5, but that's a 3. And then capital F of x is equal to -23. I can show that piece. And then this x to the 2/3, when we add 1, write it as 3/3. Well, 2/3 plus 3/3, or 2/3 plus 1, is 5/3, so you're going to divide by 5/3. So that's what we did there. And we do not want this fraction over a fraction, so we're going to multiply top and bottom by the reciprocal. So when I multiply this by 3/5, those 3 cancel. The multiplying and the dividing 3 cancel. -20 divided by 5 is -4, and then 2/3 plus 3/3 is 5/3. So what we end up with is negative 4x to the 5/3 plus c, or, because some professors may want you to write it this way, to write it in radical form, this would be the cube root of x to the 5th plus capital C, but you really have to make sure that that capital C does not end up under the radical sign, or you will lose a lot of points. All right, that's it for another power rule antiderivative.